In today's lesson, we are going to learn about complex quadratic equations. Now, before we start, we need to know how to identify a complex quadratic equation. Now, let's have a look at this example. And let's assume that you start out by just simply doing the product of two binomials and you end up with an answer of x to the power of 4. That must be your first sign that this is a complex quadratic equation, because we usually do not want to end up with an x to the power of 4. The second thing that tells us that this is a complex quadratic equation is that this entire equation has something that is in common, and that is this x squared plus 3x and this x squared plus 3x. So it's got two of the same brackets in two different terms, and that is therefore in common. And therefore I know that this is a complex quadratic equation. Now what we would like to do is make this equation much easier. So we are going to create a variable called k, and then we're going to equate this k to whatever is in common in this equation. So k is now equal to x squared plus 3x, and we are going to substitute k into the place of x squared plus 3x. So instead of having this x squared plus 3x squared, we're going to have k squared. Then we're going to have minus 2, and instead of the x squared plus 3x, we're going to have k minus 8, which is equal to 0. Now this equation looks way easier, right? So this is a quadratic trinomial, which we are going to factorize. And we end up with k minus 4 and k plus 2, which is equal to 0. Now this is a zero product rule, and therefore we know that what makes this bracket 0 when k is equal to 4, and what makes this bracket equal to 0 when k is equal to minus 2. Now we at least have values for k. So what we can do next is we can substitute for k by taking this x squared plus 3x and substituting it back into k's place. So now we're going to have, instead of this k, we're going to have x squared plus 3x equal to 4. So let's write that down. X squared plus 3x is equal to 4. Or we're going to have x squared plus 3x equal to minus 2. So here we write, or x squared plus 3x is equal to minus 2. So now we end up with two quadratic trinomial equations. So we're going to move all our terms to one side, and then we have x squared plus 3x minus 4 equals 0, or x squared plus 3x plus 2 is equal to 0. Then we factorize both of these equations, and we end up with x plus 4 and x minus 1 equals 0, or x plus 2 and x plus 1 equals to 0. This is a zero product rule. This is also a zero product rule, so you know what to do. So x will be equal to minus 4, or x will be equal to 1, or x will be equal to minus 2, or x will be equal to minus 1. And there we go. So let's go and have a look at another example to make this even clearer. Now here is another example. And as you can see, in this equation, we have an equation that contains fractions. So usually what we will do is we will change all our terms into fractions, and then we will find the lowest common divisor and multiply all the way through with it, right? And if you do that, and you can try this at home, you will see that you will end up with an x to the power of 4 after we multiplied with the LCD all the way through. So that is the first sign that this should be a complex quadratic equation. And secondly, this part of this equation is in common with this part of this denominator. Okay, so now I'm just going to put this x squared minus 2x in brackets, and now I can easily see that this is exactly the same as this. So this equation has something in common, and that is a big sign that this is going to be a complex equation. So what we do is we create our own variable k, and we equate it to whatever is in common. So x squared minus 2x is what is in common. As you can see, there it is as well as there. So k is equal to x squared minus 2x. So now in the place of x squared minus 2x, we're going to put k, there it is, minus 6 over 2k, and minus 2 equals 0. Now we have a way easier equation that contains fractions. So what do? Make all our terms into fractions. So we're going to have k over 1 minus 6 over 2k minus 2 over 1 equals 0. And then we are going to find the lowest common divider. And the lowest common divider between 1, 2k and 1 is a 2k, and then we simply do the following. 2k divided by 1 is 2k, 2k times k is 2k squared. And then we do the same. 2k divided by 2k is equal to 1, and 1 times minus 6 is minus 6. So I write that down, and I am already going to change the order because I know what's coming. So 2k divided by 1 is equal to 2k, and 2k times minus 2 is a minus 4k. And as you can see, this is a quadratic equation, and we are going to factorize this. So we end up with 2k minus 6 in brackets as well as k plus 1, which is equal to 0. So what makes this bracket 0? So it will be a 6 over 2, and that gives us a k which is equal to 3. And what makes this bracket is 0 when k is equal to minus 1. These are our values for k, so we do substitution of k. So this x squared minus 2x goes into k's place there as well as there. So let's write it down. X squared minus 2x equals 3, and x squared minus 2x equals minus 1. Both of these are quadratic equations, and therefore we move all our terms to one side, and this is what we end up with. Okay, excellent. And I'm going to go way quicker because you already know how this works. So we're going to factorize both of them, and we end up with x minus 3, x plus 1 equals 0, or x minus 1 equals 0. So we're only going to have 3 answers because these two brackets are exactly the same. So x will be equal to 3, or x will be equal to minus 1, or for this, x will be equal to 1. And there is our answers. And what you can do is you can test your answers because there's an x in the denominator, but all of these answers are valid. See you again soon. Bye.